Hello and welcome to the History and Value of Systems Engineering Module 1. In this component we will talk about fundamental terms of systems engineering and their definitions. So defining of a system, there are many definitions out there. So we'll read through several of them in here and talk about some of the pros and cons of each one. First one is an integrated set of elements, subsystems, or assemblies that accomplish a defined objective. These elements include products such as hardware, software, or firmware, processes, people, information, techniques, facilities, services, and other support elements. Second definition, a combination of interacting elements organized to achieve one or more stated purposes. In the third definition here, a system is an assemblage or combination of elements or parts forming a complex or unitary whole, such as a river system or transportation system. Not every set of items, facts, methods, or procedures is a system. A random group of items in this room would constitute a set with definite relationships, but it would not qualify as a system because of the absence of fundamental functional relationships. So consider some of the similarities and differences in here. The first one, integrated set of elements, and talk about objective. It uses similar terms. We hear elements throughout the second and third one as well. The second one is very short and sweet, straight to the point, right? A combination of interacting elements organized to achieve one or more stated purposes. The third one is broader, but also gives more clarity. Not every set of items, facts, methods, or procedures is a system. What this one is highlighting is the fact that the true system is defined by the functional relationships in the integrations between subcomponents. Within systems engineering, we have an interdisciplinary approach and means to enable the realization of successful systems. It focuses on defining customer needs and required functionality early in the development cycle, documenting requirements, and then proceeding with design synthesis and system validation while considering the complete problem: operations, cost and schedule, performance, training and support, test, manufacturing, and disposal. Systems engineering considers both the business and the technical needs of all customers with the goal of providing a quality product that meets the user's needs. The second one on here, an iterative process of top-down synthesis, development, and operation of real-world system that satisfies, in a near optimal manner, the full range of requirements for a system. And the third one, a discipline that concentrates on the design and application of the whole as distinct from the parts. It involves looking at a problem through its entirety, taking into account all the facets and all the variables, and relating the social to the technical aspect. Consider the keywords that emerge from these definitions. Interdisciplinary, considering the completeness of the problem, business and technical needs. Iterative, top-down. Design, application of the whole. Social to the technical aspect. All these things are fundamental themes that you'll see integrated throughout systems engineering. Other definitions: a systems engineer, an engineer educated, trained, and experienced in the field of systems engineering. I personally don't like the definition of systems engineer that also includes the term system engineering, but that is what INCOSA uses. The reality is what they're trying to say is that they are educated and trained and experienced in the concept of systems thinking and systems methodologies. Systems engineering process is defined as a predefined set of activities selectively used to accomplish system engineering tasks. The key word here is predefined. This is not an ad hoc type of basis. And then systems engineering effort. Systems engineering effort integrates multiple disciplines and specialty groups into a set of activities that proceed from concept to production and to operation. Systems engineering effort considers both the business and technical needs of all stakeholders with the goal of providing a quality system that meets their needs. The key themes in this one here is that it is not just a technical component. There is a human and business side of it. So there's a combination of both technical skills as well as soft skills that are both critical to success for a true systems engineering effort. One of the key systems engineering job is to understand the language of the project. Their responsibility is to make sure that everybody uses the same terms. Ideally, this would be overall throughout an enterprise organization, but at the very least within a specific project. Does a subsystem mean the same from one person to another? Does one person hear a subsystem and think of themselves as a subsystem, or do they think of themselves as the whole system and everybody else underneath them is a subsystem. It's important to be very clear about that because those types of discrepancies can result in miscommunications, misunderstanding of requirements, or not in understanding the integrations between these subsystems or areas. It's important to support clear and unambiguous communication and defining of the system for elements, functions, operations, and associated processes. Both critical and terminology issues will arise. People use different terminology for the same concept is referred to as ambiguity, and people using the same terminology for different concepts is considered overloading. Both critical terminology issues can cause issues because sub-elements truly need to be on the same page in order to be successful within the system. In the hierarchy of system elements, a system is an integrated set of elements, subsystems, or assemblies that accomplish a defined objective. These elements include products such as hardware, software, firmware, processes, people, information, techniques, facilities, services, and other support elements. An element or segment is a major product, service, or facility of the system, such as the aircraft element of an air transportation system. In a subsystem, an integrated set of assemblies, components, and parts which performs a cleanly and clearly separated function involving similar technical skills or a separate supplier. Examples on an aircraft onboard communication subsystem or an airport control tower as a subsystem of the air transportation system. If those two hierarchical levels are involved in a given system, the lower is conveniently called a subsystem. So use that aviation example. If the top is truly an air transportation system, then the element is an aircraft. Within that element, there will be subsystems, such as the control tower, communication components, etc., that all have to work together for the system, which is the air transportation, to be successful. Going further down, you have assembly, subassembly, component, and then part. That further breaks down in that tree. An assembly is an integrated set of components and or subassemblies that comprise a defined part of the subsystem. A subassembly is an integrated set of components and or parts that comprise a well-defined portion of the assembly. A component is comprised of multiple parts, and then the part is the lowest level of separately identifiable items. So an assembly, if you look at a computer, it has a screen, a keyboard, a docking station, etc. All those are assemblies. However, a subassembly might be just the screen or just the keyboard. Going down to the component, you could have one particular piece of a subassembly or even a part, which could be individual resistors or terminals that go into the computer. So in summary, undefined or inconsistent system terminology reduces systems effectiveness. A good system engineer will ensure that acceptable terminology is established very early in the program and that this terminology is communicated to all. While these definitions we gave you are consistent throughout systems engineering and are strongly encouraged to be used, I want to make sure to be clear there is some variance from organization to organization and industry to industry. If an industry requires it to be called a certain thing, or a particular nuance of an organization wants to call something an element as opposed to a sub-element, that's perfectly okay. What's most important is that it is consistently used in that term and that it is consistently understood throughout that organization.